best way to look into something like hyperbola is to keep comparing it with the ellipse, right? Even though they look very different. But right off the bat, the hyperbola is not a closed curve. And the reason is obvious, right? You see that the curves are extending, right, to positive or negative infinity. If you go to the far right, far left. Now, you know that in ellipse, right, we tend to call ellipse a horizontal stretched ellipse, right, or a vertically stretched ellipse. So in this case, we're going to call it a horizontally opening hyperbola. Now, the way we consider, like, which way it opens, do you see that the two branches, right, they are sort of like a facing one way or the other? If they're facing to the right and left, the two branches, okay, not like going this way, right? So it's almost like a parabola. Do you see that? Like a rotating parabola to the right or left. So you have two parabolic-like, but in this case, it's actually hyperbolic-like, right? Two branches of hyperbola opening to the right or left. That's a horizontally opening parabola. I guess what a vertically opening parabola is going to look like, not parabola, hyperbola. You're going to turn this whole graph vertically, right? Let the two branches go opening up and down. And we do have some terms that are, quite similar to the ellipse. So we do have a center of the graph, right? And we have two foci, right, or foci, and the two vertices. But you see a big difference, in ellipse, the foci are closer to the center, right, compared to the vertices, right? Vertices are a little bit far away, right, from the center. But now this is exactly opposite. Okay, vertices are closer, foci are on the outside. Now in the ellipse, you have two axes, right? The major axis, and the minor axis. But for hyperbola, you have only one axis, which is the so-called the transverse axis. Okay. But if you remember, the major axis in ellipse is that segment connecting the two vertices. Right? Remember that? And in this case, it's exactly the same. Even though we don't call it major axis, the transverse axis is the segment that's connecting the two vertices. But the reason why in ellipse we call that segment between the two vertices the major axis is that segment is the longest distance between 2 points you can ever pick on the ellipse. But now the transverse axis will be the shortest segment that measures the distance, which is also the shortest distance between 2 points that you pick on the hyperbola, but one on this branch, the other on the other branch. So for example, if you pick a point here and another point over there, do you see that the distance is obviously longer than the transverse axis? So this is like the closest the 2 points you can ever get on, two branches, right? One on each branch. Okay. If you're curious, like how the geometric definition, will be for the hyperbola, right? So that you can also compare with the geometric definition of the ellipse. Who still remember geometrically? How do we find points, that will be on ellipse, or how do we define an ellipse in a pure geometric way? Do you still remember? Even though we didn't emphasize it, because we just start with that definition. I showed you some, simulation, right? Then we just go to deal with algebra. Anyone still remember? Oh, yeah, Emily? Add up to be the same constant, right? So it's the sum of the distances from a point on the ellipse to the two foci is a constant, right? So the trajectory for such a point will be ellipse. Now, you just have to change what we just said, just a tiny bit. Then you're going to get the definition of the hyperbola. So instead of referring to the sum of the distances, we're going to refer to the difference of the two distances. So now basically, all the points on a hyperbola whose distance from two foci will subtract and still gives you a constant. So it's the difference of the two distances to be a constant, and that's going to be the hyperbola. Therefore, things are very comparable, right? Not to mention, now, of course, you see on the packet, what the equation for the hyperbola is going to look like. But the way you can remember or see how straightforward that formula for the hyperbola is, let me help you to recall the standard equation of an ellipse. Let's go with a horizontal ellipse, right? So that will be x squared over a squared, right, plus y squared over b squared equals 1. Okay, and also a must be greater than b, right? A is called the semi-major axis, b is the semi-minor axis, right? And it turns out to get the equation for a hyperbola, all you have to do is, well, I guess that just take b and change it into bi. So you might say, what is I? You guys know what I is? It's a number, right? It's an imaginary unit, which means that I squared is -1. Okay? So now let's see what happens if you were to write down an equation that you thought it's going to be an ellipse, but instead of taking a b, wherever you see the b, replace it with bi, x squared over a squared, right? That doesn't change at all, right? Plus y squared over, now squaring a b, but now squaring a b and an I, right? So you get b squared, right? I squared equals 1, right? But what is I squared? -1, right? So x squared over a squared minus y squared over b squared, oops, is 1. And turns out that this is the standard form of the equation of a horizontally opening hyperbola. It's that easy. And the reason why I'm telling you this, which is not in the packet, because for some reason that the author didn't, put it on. I mean, you should ask, like, one of the students in the PM session yesterday asked me that why didn't it have the names for the two endpoints of the minor axis? Well, we call the endpoints of a major axis the vertices, right? At this point, you should ask, what's wrong with calling something else, some kind of an axis, if you already have the so-called transverse axis, right, for the things that have to do with the A, right, because that's the distance between two vertices, right? Do we have another axis, just like we had a minor axis, right, in ellipse? Well, it turns out some other people, I'm not saying this guy, they call the distance between the two vertices the real axis. And then they're going to call something that you don't see on a graph. But the length of something, which is the same as 2 times the b, the imaginary axis. And I hope you see why they call the things to do with the b the imaginary axis. Because all it takes is to go from an ellipse to a hyperbola by making the b imaginary. Okay? And that means, A is so-called the semi-real axis, or the B is the semi-imaginary axis. Okay, but unfortunately, if you want to go with older book, A is the semi-transverse axis, but we don't have a name for the B, right? It's just whatever it is. Okay. The one on the right that I circled, see that the graph is hyperbola. That's corresponding to the one that has a negative sign in between. Okay. Now, the way you can remember, if this version is for a horizontally opening parabola, sorry, hyperbola, or if you take a look at the I believe the second page, right, of your packet, 10.2, you see that there is another version, right, for a vertically opening hyperbola, right, the one up there, right, it has, instead of x squared over a squared minus y squared over b squared, for the vertical opening hyperbola, you have y squared over a squared minus x squared over b squared. How do you remember which one is vertical, which one is horizontal? So again, you can do some same strategy like we did with the ellipse. All you have to do is just take a look at which term gets the negative sign, right? Because that's the weird thing going on, right? So let's say here, the y term gets the negative sign. You know what that means? I mean, it's the y, right, that's acting a bit odd, right? Instead, the x is perfectly fine because it gets the plus sign. So hopefully you remember that this is a horizontal opening hyperbola. Since y gets the negative. Okay. Or the other way around, right? So if you're looking at the vertical one, you see that y squared over a squared minus x squared over b squared. So now the x gets the negative, right? But the y gets the positive, the over plus sign, right? So if the y is positive, that means it opens, vertically. Either way, all right? So whatever you do, you need to remember the standard form for a horizontal opening and vertically opening hyperbola. Okay. Now, scroll down. All right, let's take a look at this expression. So this is only for hyperbola. But I know that it looks so similar to the one that you saw from the ellipse, right? Not to mention that people probably like this the most, since that looks just like the Pythagorean theorem, right? Now, anyone knows a similar expression bridging all the constants A, B, C for the ellipse? It looks similar but different. I probably have c squared equal to a squared plus b squared. What about ellipse? C squared e squared equals a squared minus b squared, right? So again, you could put it down if you want. So basically, let's say a squared is b squared plus c squared, and this is for the ellipse. Ellipse, is that the, okay, something like that. Now notice that in the ellipse, A is the biggest guy. A is the major axis, right? Semi-major axis. But when it comes to the hyperbola, C is the biggest. But my question for you guys is, does the B has to be greater or smaller than the C in the ellipse? Does it has to be? Say in the ellipse, does the B and the C must have some kind of a, or does the B have to be greater than C or less than C? No, right? It could be anything, right? It could be the same. The same thing here for the hyperbola. All we know is C is the biggest guy. But when it comes to A and B, they could be the same. They could be different, right? One's bigger than the other, right? It doesn't matter. But C has to be the biggest one. Okay. Now, but you do know, since the hyperbola looks very different, right? It's not even close anymore. It has something imaginary going on, which is not going to really affect your understanding, but there's a reason why we have to study hyperbola, because most of the things that you know about ellipse could be, somewhat, right, like transferred to, the hyperbola as long as you do some fine tuning. But there's something that the hyperbola has, but not the ellipse. This is the asymptotes. So I'm glad that we choose to do the chapter 10 after the polynomial rational functions, because now I'm sure that everyone knows what a asymptote is, right? So the asymptote, unless I say it's a curved asymptote, asymptote is by design a straight line. And it's going to show up as a dashed straight line. But you know that lines could be either horizontal, vertical, or an inclined, right, or a slant line. But in this case, we're looking at two possibilities, for hyperbola: a horizontal opening hyperbola, a vertical opening hyperbola. But either way, it's going to have two slant asymptotes. Okay, and you need to find out the equation of both slant asymptotes. But it's very straightforward, and that's why I do typed up something. So let me make sure that I go over the logic behind the algebra here. But again, don't feel like that there's some kind of complicated things. As long as you understand how we study this kind of sort of like an M behavior, right? Or if you know the arrow notation back in the chapter 3, right? So be honest that this is almost trivial. You just have to know that little trick to quickly find the hyperbola. Sorry, the hyperbola, the slant asymptotes for hyperbola. So now let's take a close look at let's say the first scenario. So this is now real quick. Can you guys tell me if this guy is a horizontally opening or a vertical opening hyperbola? Horizontal, right? A horizontal opening hyperbola. So see what you so what I did to go from this guy to the next version of the equation. I just separated the x and a y, right? I put the y on the other side. Nothing crazy. So now I'm gonna claim that let x and a y be as big as you want them to be. So think x to be like a trillion if you want. Take a look at the right hand side. When y is insanely big, not to mention y squared, right? Do you see that there's no point of adding that 1 anymore? So we can drop the 1, right? Or you can say that 1 is the less dominating or the non-leading term, right? So now that's how I reached the third version without a 1, right? So now you tell me, what did I do to arrive at the fourth version? So I have x squared over a squared. I have y squared over b squared. They're equal. So and manage to write the y squared by itself and having everything else on the other side. You see how that works out algebraically, right? Basically, isolating y squared, right? So one more step. What did I do to get this ultimate version? I take the square root of both sides of the equation, right? But do you see that it is that plus or minus signs that people might forget? Why do you have to add in the plus or minus? Because of the square root property you learned back in college algebra, right? When you're taking a square root, you're going to have to be open to both possibilities, right? So add in the plus or minus, which means there are two slant asymptotes, right? One with the plus, one with a minus. And let me remind you that even though that A and B, A doesn't have to be greater than A, or the other way around, but A and B are designed to be positive real numbers, just like the ellipse. It means you know the ratio of B to A is a positive number, but with the plus, that means you have a positive slope for one of the slant asymptote, and the negative sign go with the negative slope, right, of the other asymptote. And take a look at what the two asymptotes look like. For a horizontally opening hyperbola, right? So you have a slant asymptote that goes to the origin because y equals something times x without a y-intercept, right? So it'll be a line that goes through origin, but this one has a positive slope. That's going to be b over a. And the other one has a negative slope, right? It'll be negative b over a. Okay? And I'll talk about what that little rectangle with dashed line represents. But let me ask you to take a look at the two asymptotes for a vertical hyperbola. See how close they look compared to the horizontal one. So somehow, you know, the logic that I showed you, right, by going one, you know, to the next step and the next step, right, with some, you know, very straightforward algebra. So you see that, oh, this guy has b over ax, right? This guy is negative b over x. But all of a sudden, you realize there is another hyperbola, which is vertically open. And this guy has a positive a over b as a slope. This guy has negative a over b, right? How would you remember them? Well, if you have a good way, you know, you could either share it with your peers or, you know, or let me know if you want, right? But honestly, if you ask me how will I remember it, so I don't think I'll have any good way to remember it. And I'll choose not to remember the formula as is, because there's no way to me, how do I know that when A is going to go with the X, right? Or B is going to go with the X, right? Because you see that it's almost 50-50, right? If I ever mess it up, so let's say you ask me, you know, tell me the asymptotes for the vertically, you know, opening hyperbola, you know, in 5 seconds. I couldn't do it. I have to think, maybe spending another 10-20 seconds, right? But trust me that 10-20 seconds for doing the reasoning, worth it, because you guarantee to get the correct one. So now let's see the logic behind the second line of work, which is obviously representing a vertically opening hyperbola. Do you guys see that? Right? With the negative sign associated with the x, that means the y is going to be positive. It means it's going to be open to, you know, up and down. So I'm going to, again, quickly go through the same logic, right? So again, you guys think aloud together with me. Starting from the standard form of vertical opening hyperbola, throwing the term, you know, x squared over b squared to the other side, right? And that's called separating the x and y. Then you're going to claim that x and y are big. That means there's no need to keep that one anymore. And you quickly arrive at y squared over a squared equal to b squared x squared over b squared. So now remember, your goal is to find the equation of the slant asymptote. That equation has to be y equals something, right? So you're gonna isolate the y, but you're gonna get the y squared, right? Isolate it first, and I hope you see that maybe through cross multiplication. Y squared is indeed a squared times x squared over b squared. A squared times a squared over b squared. By taking the square root, you're gonna get plus or minus. Since a was on the top, therefore you have a over b x, right? So there's no way you will miss the order of the A and B in whichever case, if you do the reasoning. It took me maybe 10 seconds to explain, right? But, our brain's going to work out a lot faster, right? You don't have to tell me or explain to me or even explain to yourself because it just works. Not to mention that there's no need to remember the asymptotes in terms of A and B, even the logic that I showed you in terms of A and B. If you don't get a number to work with, then go with the numbers, and I'll show you in a second. But I seriously urge everyone to do it this way so that you don't mess up with the slopes of the asymptotes. Okay. Yeah. Now, so if you're wondering what the square, not a square, right, a rectangle with the dashed line represents, do you know that if you're given an equation about the hyperbola, you're gonna know what A, B's are, right? So let's say A is 2, B is 3. So in order to graph the hyperbola, or even just sketching the hyperbola, to make it as accurate as you can be, even if it's just a sketch, and also to reflect that you do have two asymptotes. What you want to do is, if it's a horizontally opening hyperbola, you're going to find the origin, which is the center of the hyperbola. Right, go to the left and the right by 8 units to get the two vertices. Okay, then going up and down by B units, right, to reach the other two so-called vertices, right, but we didn't call them that. And do you see that those 4 points will confine a region, right? We'll put, or you can actually draw a rectangle out of those 4 points. Okay, so just put 2 vertical lines at the 2 vertices, 2 horizontal lines at the other 2, so-called vertices. Now, what we're going to do with that rectangle is to draw 2 diagonals. And of course, it's going to go through the center, right? The 2 diagonals are guaranteed to be the asymptotes. You don't have to know the equation. You just know that the graph's going to be, the asymptote. And you can probably see why, right? For example, the one that goes from the bottom left to the top right, do you see that this line must have a slope to be B over A? Because that's how wide, that triangle is, right? That's A units here. That's the rung. The rise is B over A, right? And the other one's going to be symmetrical. The same thing here. Getting a vertical hyperbola, right? Go find A's and B. But it's vertical, there's, opening vertically, right? That means you're going to go up and down by 8 units to find those 2 vertices. But going left and right to find those 2 so-called vertices and draw lines, right, to form a rectangle. And quickly draw 2 diagonals to get the asymptotes. Now, the point is, where are you getting the asymptotes, even though they're not going to be even on the graph? Because once you have the 2 vertices, do you see that the way to graph the hyperbola is to start from, let's say, one of the vertices and let it open in a way, right, so that it will get closer and closer to the slant asymptotes, but never cross it. Let it open to the right or left if it's a horizontally open hyperbola. Or if it's a vertical open hyperbola, start from a vertex, right? Then let it open almost like a parabola, right? But let it open towards, up or down, and you see that the 2 branches, right, are going to be getting closer and closer to the asymptotes. That means if you do have to graph, which I don't think is going to happen, in a test, where you're having the 2 asymptotes, I'm not expecting a hyperbola going like this. Do you see what's wrong with the one I just draw? It's not respecting the asymptotes. It has to be the one that you see from, the book, right? They're getting closer, right? They're approaching the asymptotes. Right? But again, it's a sketch, right? So why are we getting that crazy about that? But I'll say that back in the old days that we do, since people are taking tests, maybe 10, 20 years ago on paper, then they have to do these things. Anyway, now, So much for getting all the graphic, features, right, and the concepts, defined or introduced also by comparing all of them with, the ellipse, right? The only new things that you learn for hyperbola are the asymptotes, but I hope that you don't remember these things as is. Please figure out the logic behind them, okay? So now I hope that examples A and a B on whatever page 3 and 4, actually on page 3, right, seems very similar to the ones you had yesterday, right? So let's work them out. So given an equation, right, quadratically in x and y, so I want to identify foci center, length of a transverse axis, length of O. I believe that it's probably the older version of the textbook because we're using the version edition, 7th edition. I think that when I composed the notes back then, it was like 10 years ago, that was probably the 6th edition. Anyway, and it turns out that they do have a fancy name for the other axes associated with a B, right? Conjugate axes, right? But I don't think that I've ever seen that on, in a question bank, right? Anyway, so the transverse axis is referring to 2A. The conjugate axis is referring to the 2B, just like you have the major and minor, right? Not that big of a deal. But we do need to know what the vertices are. So start from rewriting the equation. By dividing out 144, because you know that no matter what happens, you must have a 1 on the other side of the equation. And it turns out numbers works out, right? Because this guy's crazy about those easy numbers. So you have x squared over 16 minus y squared over 9. And please understand that this is a coincidence, or I mean, this guy prepared for the numbers, right? So you don't expect that the numbers 9 and the 16, like in front of x and y, later get swapped and get into the bottom. Okay? It's not guaranteed. You have 1. So at this point, you should be able to identify A and a B. So what do you say? How much is A? Given the standard form of this, just to remind you, a horizontally opening hyperbola. What do you think will be A? 4. It's square root of 16. And the B must be square root of 9, right, which is 3. But listen to this. Let's say if I were to ask a student, why you take the 16 as, square root of A? So the student said, oh, we know that A is always greater than B. Therefore, 16 must be A squared. Does that sound right? For hyperbola, does A has to be greater than the B? No. It's true for ellipse, right? For hyperbola, A doesn't have to be greater than B. So in this case, the reason why, the proper way to say it, why you're taking the 16 to be the A squared is this is the thing that's associated with a positive term. Okay. Now take a look at the standard form of the two equations on page 2. Once again, on the top, you see that you have two equations, right? X squared over A squared minus y squared over b squared. That's a horizontal opening hyperbola. But now when it comes to the vertical one, you have y squared over a squared minus x squared over b squared. Do you see that the A will always come with the term that has a positive sign in front? And then B is always going to be coming with the term that has a negative sign, right? So therefore, in this case, doesn't matter if this number is going to be greater than that one or smaller, even though this is, let's say 4 over here. you're still going to take that as a squared because that's the one that sticks with the positive term. Okay. No, I'm not saying a has to be positive no matter what. I'm saying that it is always that number, or you know what, go up to here. It's always that number that gets underneath the positive term. That's the one that we're going to call it a squared, right? And of course, the b is going to be the one associated with the negative term. But you know that whichever term is positive tells you which way it opens, right? So please also put everything together like that. Now, getting the a and b, how do we find the c if we need to know the foci? So in this case, c is the largest guy, right? That means you're going to take square root of a squared plus b squared, which is going to be 5, right? 3, 4, 5. All right, so now I think that we have everything we need, right? So now, since we did that already with the ellipse, right? So it's probably not that hard for you to put everything together to find the foci, the vertices, right? But I still suggest, just in case in the test that, maybe just because you have to remember that many things and, you're performing under pressure, things might not work out. And, it could be a little mistake. You know that those questions from the question bank, they're always going to have distracting, options that look so close. But if you mess about anything that, you might end up choosing the wrong one. So I have a horizontally opening hyperbola, right? This looks like something like this, right? 2 branches opening to the left and right. So these two are the 2 vertices, right? So if you want, you can call it V1, V2, so vertices, right? Where are the foci? You guys tell me roughly where the foci is supposed to be. Here on the vertical axis, on the horizontal axis, would it be a little bit closer to the center compared to the vertices, or would it be farther away? What are the foci? For hyperbola, the foci will be farther away, right, from the center compared to the vertices. But what is going to be ellipse or hyperbola? The vertices and the foci will always line up. There's no way you can get these on the vertical axis in this case. It's a horizontal opening hyperbola. So you have F1, F2, right? Now, how far is a vertex away from the center? Which number should we use? A, B, or C? The vertex is still associated with A. Does it make sense? That was just like the the ellipse. Then what about the foci? How many units away from the center are we looking at? The foci is going to again associate it with C. Okay. Therefore, use that sketch to remind you what those 2 foci and vertices are. So let's say vertices are located at plus or minus A, right? What is A? 4, plus or minus 4, comma 0, right? Foci are located at plus or minus C, comma 0. Okay? Is that all? I mean, the length of the transverse axis, right? Length of the transverse axis. Sorry, let me scroll to the right a little bit. Axis is 2A, which is 8, right? Then the length of the conjugate axis will be 2B right? And that'll be 6, right? All right. So now I'm gonna have the screen like that with the problem letter A. We figure it out, and I'll let you try letter B. But feel free to take a break, then come back. But I'll only wait for, let's say, 5 minutes before I start talking about letter B, because I hope try not to take too long, for the break, because I have to leave a bit early. Right. So feel free to stay and work on letter B. I'll wait for 5 minutes, or if you want to do some stretch or get some water or do some restrooms, go ahead. But come back, please, before, in 5 minutes. I don't think so, because I don't remember the word any question asking or can con. Yeah, but like I said, the notes was from 10 years ago. But I'll double check, right? But you know that, guys, please understand, even in the test and exam, if you seriously think that you've never seen that something, right, in our class, sometimes it'll be a wording or whatever in a test, you can ask for clarification, right? There's something that I cannot comment, I'll be very straightforward. I cannot say anything. If I feel like I can clarify, I'll let you know. Is the conjugate axis, you don't know what that is, just ask me. All right. Let me put the work up for letter B so you can check that. She already finished it. And also at the same time, if you think that you're fine with letter B, then take a look at letter C. Right? Because again, it's a very similar problem, just like the one we did for ellipse, right? But instead of getting these equations, right, figure out what the graph look like or extracting those informations, you're gonna go back, right, by using those information about foci, vertices, to find out the equation of a hyperbola. Anyway, so for letter B, so again, the same thing as you will have to do when it comes to rewriting the equation, right? So divide out the constant 36, okay? So you're looking at y squared over 4 minus x squared over 9. So as you know that since the y term has a plus sign in front, that means there's a vertically opening hyperbola. And when it comes to A and B, so now guess what? 4 will be the A square. You're getting A to be 2, right? And B will be square root of 9, which is 3. So remember what I said? In this case, A doesn't have to be greater than B. So it is whatever number that's coming together with the positive term, right? The positive quadratic term that will become A squared. Okay, and given the A and the B, you can figure it out what the C is, right? The same way, just like the Pythagorean theorem. Oops. Okay, so that's going to be so what is that? Radical 13. Oops. All right, so and I still suggest that you quickly sketch the hyperbola to have an idea what or where those points you should be looking at, right? It's a vertical opening hyperbola, so going up and down. Oops. Right, so those two are the vertices, right? B1, B2, and the foci will be along the same line, but farther away, F2, right? So vertices are 0, comma, plus or minus A, since now it's on the vertical axis, right? And the foci, again, the same way, but plus or minus C. So in this case, will be plus or minus radical 13. Okay. So 2A, first will be 4, right? 2B will be 6. Any questions so far? You good? Right. Very routine, right? And you should expect the quiz and test questions at this level. So letter C, again, I'll just quickly put the work down. But pretty much there's not much I have to show you, right? Since there were very clear about where the foci and vertices are. So as you can look and see the foci, that means C has to be 10, right? The vertices tells us that we're what the A has to be, right? So given the C and the A, so you find the B, right, by taking the square root of C squared minus A squared, right? Notice the difference? Because now we know the biggest guy, right, and one of the small guy, then we're finding the other guy, right? So that'll be that'll be 8. So 100 minus 36, right? Get 64 square root, get 8. So that's a horizontal opening hyperbola, right? Since the two vertices and foci are on the horizontal axis, that means you're looking at x squared over a squared minus y squared over b squared equals 1. So that translated to x squared over 36, right? A squared 36 minus y squared over 64 equals 1. Okay, that's all. All right. Now, just like in ellipse, the ultimate goal is to be able to rewrite a more general, quadratic equations in x and y into the standard form of the hyperbola. Then we can also identify foci and vertices, even the asymptotes. Since I think that we should have done that, right? Oh yeah. You know what? So we will see about the asymptotes. I forgot to do it, but it's okay. We have one more example, and I'll show you even in a more trickier case when the hyperbola has been shifted, right? So how we're gonna get the equation about asymptotes, right? Anyway, now in ellipse we had this big chart, right? Table summarizes, the translated or the shifted form of the two kinds of ellipse, right? And in this case, hyperbola, right? Where the center is going to be located after you shift, how the translated axis is going to look like, right? And also where the vertices are. Potentially, you could also be asked for the foci after the translated operation. But like I said, this is hard to memorize if you don't try to understand what's going on, right? And also there's some algebra you have to do. If you're given some ugly equations like that, you have to complete a square to get yourself the standard equation, right? So you can extract that, all the things. Okay, so let's quickly do that. So now again, everyone please take notes because you have the problem with the ellipse, right? Complete a square and do all of that. So now you have a second chance, right, to do something almost the same, and also pay attention to that little difference. And we have one more coming up that's for the parabola. All right, so we will start with a bit rewriting of the original. Oh, you know what? We don't have to do that since things are actually in a good order. I just have to, put some space in between to let you know that what we're gonna do next. Okay. So yeah. So you need to add something here, right, or subtract off something, and then we have. Oh, unfortunately, you have a negative leading coefficient for the y. All right, so 250y. Then I'm going to have some space here, right? Later, I'm going to add or subtract the number. Then I don't like this constant on the left. Let's do it to the other side. You don't need it for the completing square. So 489. So that little technique of a completing square by always adding the square of half the b, right, or b over 2, will only work if you have trivial leading coefficient. Unfortunately, it's not the case. Let's fact out the 4 from the first two guys. All right, let's put a big arrow bracket. Now take the 4 out, you get x squared minus 6x, right? If you want to check, put the 4 back in, right? When it hits the second term, you get 24. To complete the square, we're going to add the square of b over 2, right? So b is negative 6, so negative 6 over 2. Then you're going to quickly subtract it off just to balance everything. Okay. So now the second part gets a bit, non-trivial. So you have a negative coefficient to fact out, right? Let's say it will be a negative 25 taken out from the second big pair of bracket. So now you have the y squared left over, but please be careful with the sign change. Take out a negative coefficient, right? So this guy becomes a minus, right? And it's going to be negative, or minus, right? 10y. And again, always do a quick sanity check. Put the negative 25 back in. It hits the first term, get you negative 25y squared. When it hits the second term, 2 negative, make it positive. It's positive 250, right? Complete a square for the y the same way as you did with for the x. Take the b, -10, right? Divide that by 2, and add the square of this guy, right? Then subtract it off. Okay, you have 489. So now you can complete the square, right? By factoring this guy, and all you have to do is just start with the x, then take whatever this number is in the parentheses. So it'll be -3, right? Close the parentheses, square it, right? Then minus, this is -3 square, +9, right? You're gonna subtract the 9. Don't forget you still have the bracket and the 4 in front. Okay. Now come over here. Those three terms can be factored as y, right? Starts with y, and then you have -10 over 2, which is -5. Close the parentheses, square it, right? Here you have -5 squared will be +25, but you should subtract it, so it'll be -25. Bracket, -25, right? And it will be 489. Right? You guys okay so far? Okay. Now distribute the 4, so you get 4x minus 3 squared, right? When 4 hits the 9, you get -36, 36. Then you still have -25, right? Distribute it into the bracket, so you get y minus 5 squared with the -25. But -25 hits another -25 will be positive 625. Right. You don't have to do mental math, right? It's just, use the calculator. 489. So keep the two quadratic, parts. Get those two constants, throw them to the right-hand side. So let's see, what did you get? I kind of forgot. Oh, -100. All right, so for some reason. So now what do we do? To get the standard form, we need to divide all the constant on the right-hand side to get you a 1, right? So to do that, whatever that constant is, it will never be 0, right? So divide out -10, -100. So the first term, not the first term, right? The first part becomes x minus 3. And it turns out that you can divide out the 4, right, to get -25. Okay. And here you get the -25 and -100, right? So it becomes positive y minus 5 over 4 equals 1. Okay. So let me pause. Any questions so far, especially as I go from the line over here to the next one? Algebraically, any issues? Like, how did I figure that the number underneath the first quadratic part is -25? You guys all see it? Divide out the 4, right? But now, what makes the sign positive in the second part? Because two negative number divide, right? It's a positive number, and the number becomes 4 because it's 4. It's 100 divided by 25, right? To divide it out, because we do need on the top just the squares, right? Nothing in front. Okay, so now what are we looking at when it comes to A and B? What do you say? Which number? Now I think that you're better off to put that negative sign in the front, right? Don't let it confuse you that you thought that, oh, a squared, b squared can be negative. No. Yeah, which number? 4 or 25 is going to get you a squared. Why is that 4? It is the number underneath the term that has a positive sign, right? There you go. So A is radical 4, square root of 4. It will be 2, right? B is going to be square root of 25. It will be 5, right? And once you get them, figure out what the C is. C is the biggest guy. So you go by A squared plus B squared. Okay, so there'll be, well, that 29, square root 29. Numbers don't have to be nice, even in the test, right? So please be aware of that. So now we have everything we need, right? So we know A, B, and C. We know the standard form, right? So now let's deal with such a translated, hyperbola. Because we need to know everything we could about geometry. First off, let's say, where do you think the center will be? Since it has been shifted. Because the center is now not as trivial as the origin, right? You guys figure that the center, I think that they call it H, comma K, right? You see what that point is? 3, right? And a 5. Yeah. So I wish that, they had like a plus sign somewhere, then you know that the H and K will be whatever number you subtract from the X or the Y. But in this case, it's 3, 5. That means that you're shifting the hyperbola to the right by 3 units and to the up, right, by 5 units. What kind of hyperbola is that? Is a horizontal or vertical hyperbola? It is a vertical, right? Since you have the y term that gets the positive sign. So now, just in case you lose track of, everything, how about we sketch a, hyperbola, which is vertically opening, with the center to be not at origin, but 3, 5, right? So let's say this is 3, right? This is 5, and I have the center, right? So now, since it opens vertically, right? So let's draw this kind of axis, right? And it will be a hyperbola that's going up, right? Now remember, that's the center. Okay. Now the sketch is nowhere near being accurate when it comes to the size, right? But at least that the orientation is fine and where the center has to be. So I'm going to use it to remind myself where the vertices and foci. Okay, so vertices V1, V2 are here, right? Foci are one up there, one down there. Okay. So now, instead of going through everything in this big table to find out what A's, B's, and H and K is, right? Can we just quickly read out the coordinates of the the vertices? Vertices. So what do you say? You see that the vertices are on this line, right? Remember that the center is at 3, 5. Don't you think that you can just go up by 8 units, go down by 8 units to get the 2 vertices, and go up by C, go down by C to get the 2 foci, right? So if we're looking at the center, which is 3, 5, right? If I go up and down, it doesn't change the horizontal coordinates. The vertical coordinate is going to be 5, right? But plus or minus A. A is what? 2, right? You guys all agree? This is where the vertices are. And you should do that instead of going through all the conclusions. Okay? Now, what about foci? Can you guys do the same thing for me? I'm going to start with 3 and 5, right? Where the center is. What do I do with the vertical coordinates of the foci? It'll be 5, then what? Plus or minus c, which is 29, radical 29. Right, but whatever it is, right? Now, what else we need? I think that maybe 2a, right? So it'll be 4, 2b will be 10, right? They're trivial. But what is not trivial is what about the asymptotes, right? Or slant asymptote. Now's the time, right, for us to practice, how that logic works out without remembering whether it's going to be A over B, B over A, not to mention the thing has been shifted, right? So let's start with the original equation, the standard form, right? So let's take that. I'm going to write it as negative x minus 3, square over 25, right? Plus y minus 5 square over 4 equals 1, right? That's what we've got. What's the first step to do the logic, like assuming y and x are big, then, right? You say that just separate the y and x, right? So let's say go ahead and throw this guy to the right hand side. If you want, you can do the other side, but why bother, right? So throw the negative things to the other side. So y minus 5 square over 4 equals x minus 3 square over 25, right, plus 1. Right, you guys okay with that? So now let's say x and y are big. How big that is? Well, however big you want, right? So plus minus infinity. By assuming that we can drop the 1, right? So all we have to look at is that's a y. Y minus 5 square over 4 equals x minus 3 square over 25. So then you need to isolate the y, right? So you're going to put just the y, but in this case, y minus 5 square by itself, right? Just multiply by 4. So you get 4 x minus 3 square over 25, right? So now what? To get 2 asymptotes, we need to square root, right? Taking the square root, you get y minus 5. On the left, on the right-hand side, it's 2, right, over 5 x minus 3, right? Am I right? Did I miss anything? I thought there are 2 asymptotes, plus or minus. And that's it. Now, do these two equations look like equations of a line? Let's say if you go with a plus, y minus 5 equals 2 over 5 x minus 3. Does that look like an equation of a line to you? Did we have a name for an equation in such a form in college algebra? It's called point slope form, right? You know what the slope is supposed to be. It came from A, B, or A over B or B over A, right? The point, guess what that point is? That was the center, right, of the ellipse after you shift it. So now let's see if it makes sense. So I claim that there are 2 asymptotes. Both of them is going to go through a point. which is 3 and 5, right? So it's going to be, so now let me draw straight lines because that will be easier to do over here. But you know they're supposed to be dashed lines. Well, guess the equation of this line has to be the line that goes through a point 3 and a 5 that has a positive slope, right? Now positive slope, if you remember, is 2/5. And the other one is, again, the same exact point, but a negative slope. Take a look at that, right? That's all you have to do, right? Why would you go through all that many conclusions and find out what A's and B's or where they're gonna go, right? And end up messing around, you know, because like you have seen, so that might be one of the options in the test or the final. There will be options with 5/2. You have options with x minus 5, y minus 3. They know people's gonna like to memorize these things, and there's a big chance that they're gonna mess up. Don't do it. Go through the logic. Right? That's gonna ease up the whole process of you preparing for the test because you don't memorize 1,000 things, but only the ones that you seriously have to remember. But you know, once you get the spreadsheets, put them down, right? So what I suggest you do, you know, when you get a chance, maybe later today, is you see that I forgot to do the asymptotes, right? Find out the equation for the asymptotes in letter B, letter A and B. You should try the same, you know, techniques, right? Starting from the standard equation, move, you know, the term to the other side, drop the least, you know, non-leading term, take a square root, get yourself two asymptote equations, right? So those are the two things that I haven't done, right? Anyway, so again, let me probably leave the screen like that for just, you know, a brief moment. So again, any questions so far about the hyperbola? Okay, because you know the quiz on Monday will be about 10.1 and 10.2. So ellipse and hyperbola. Okay. Yep. Yeah. How do I turn? Okay, so you're talking about that equation over here, x minus 3 squared minus 9 into 4 times. Okay, yeah. All right. Yeah. If there are no questions, so let's take a look at what we could do about 10.3. All right, parabola. So as you can see that I didn't put any exercise, right, for you to, you know, write anything except for the last one. That's just pretty much completing the square thing, right? So of course, you know, there's some terminologies that we could quickly take a look. So parabola, right? And there's only one branch because a lot of people think that parabola looks like a hyperbola, but they are still quite different, right? Not to mention that, you know, there's only one branch here, but we do have the so-called vertex and a focus. There's only one of them. One vertex, one focus, and also we have a symmetry axis or axis of symmetry. That is the line that will go through both the vertex and the focus. So the way you draw the hyperbola, sorry, not hyperbola, parabola, is to start from the vertex and curve towards the focus and make sure that the curve is symmetric about the axis of symmetry. So basically, you just have to locate where the vertex is and which side the focus is on, right, relative to the vertex, right, to make sure it curves, in a certain way. But there's a weird guy called directrix, which is a line, and that's actually a reference line. So what's very strange about the parabola is it does need two references to be able to construct the curve, because we need two foci, right, for the ellipse and the hyperbola. But for parabola, we need one focus, which is a point, and a reference line. Okay, and that line is at equal distance away from the vertex as compared to the focus, but it's going to be on the other side. And this line has to be perpendicular to the axis of symmetry. Okay. Now, of course, the reason why I have to mention it is just like we have to find out the foci, right? For the ellipse and hyperbola, you need to find coordinates of vertex, the focus, and also the equation of the directrix. So the directrix is going to be either a vertical line in this case, right, or a horizontal line. We do have the parabola opens, up and down. But we start with a horizontally opening parabola because that's the ones, a little bit awkward since, everyone knows what a vertical opening parabola looks like, right? The horizontal one, that gets a bit strange. The geometry definition is also tailored to, just the focus and the directrix. So basically, all the points that are supposed to be on a parabola will always be equal distant from the focus and the directrix. Okay, so it turns out that whichever point you're looking at, measure the distance from that point to the focus and the directrix is always going to be a equal distant. Okay. But now, if we were to put a parabola centered at the origin, so this is the origin, and let's say if it's a horizontal opening, parabola, let's say open to the right, then you know that the focus has to be on the right. And let's place it at p units. Again, there's just, decide to call it p, right, instead of c for some reason. But anyway, so c units to the right of the vertex. And since that the directrix must be equal distant from the vertex, but on the other side of the focus, so you're looking at a vertical line, which will be to the left of the vertex by p units. So if the p is positive, let's say if, right, in this case, p is positive, so the directrix is going to be x equals negative p, right? A line that has, no room for the y, x equals negative p, that's a vertical line. That means, it's not that hard to find out the equation of the directrix if you know where it's supposed to be, right? And also the location of the focus. There's only one of them, right? It's to the right or the left, right? Depends on which way the parabola opens, right? And it's on the horizontal axis before you're shifting it. And what? There's only one constant you have to track, right? Instead of a and b, right, or even c, you have just p. So now let's take a look at what the equation looks like for, the parabola we just talked about. A rightward opening parabola centered at the origin with the distance from the focus to the vertex, which is p, right? And the direction is also going to be p units to the other side. And that equation looks like this. So you have a constant 4p as the coefficient of x, and that's going to be on the right-hand side. The left-hand side is going to be y squared. But you know that sometimes people always want to think about the parabola the way that they did with the quadratic function, right? So in this case, do you see that the y is the guy gets squared, not x? If you're so used to ax squared plus bx plus c, right? That's the generic form of the quadratic function, right? Not anymore about the x, right? About the y. So however you can remember it. So maybe I'll say whichever variable that does not get the square is how you're gonna open the parabola. So in this case, it's opening in the x direction, right? Now, the way I can tell that if it opens to the right or left, it depends on the p. If p is positive, opens to the right. Otherwise, opens to the left. Now take a look at the vertical parabola. And now it is the x gets the square, right? Because now the y doesn't get a square. So this is the way that the parabola should open. And again, if the p is positive, the parabola opens upward, the vertical opening parabola. Otherwise, opens downward. Okay, that means you just have to track, how much the p is. But as you turn it, right, vertically, so the focus is going to be on the vertical axis, right? And so does the directrix, right? Intersects the vertical axis, but being a horizontal line. And the way you can put the horizontal line, that will be y equals something. Okay, and you see that since the direction is always going to be on the opposite side of the vertex, if the focus is on the y-axis 0, comma p, then the direction is going to be down there, right? Y equals negative p. And I actually did type up, these examples. We could have done that, but I don't see the point of doing it. Not to mention, it's just not worth spending time to go over something that's so straightforward. So you have an equation, y squared equals 12x. Right off the back, you need to know it's a horizontal opening parabola, right? Not to mention, it's a rightward opening parabola because the p-value, right, the number in front of x is 4p, is 12, right? So p is, all right, I'm just reminding me that I have 5 minutes left. Out of 3, right? That means it opens to the right. Then how would you get the foci, the focus, the vertex, which is the origin, right, and the directrix, right? Isn't that simple enough? Just go by the p, right? But you have to know where the p goes. P units to the right of the vertex to get you the focus, right? And a vertical line that's located on the other side. Okay, and that's a horizontal opening parabola. Right. So now take a look at something called latus rectum. So, but I think that's not very common now for you guys to work out, that thing. But that's still, a very simple measurement. You may not appreciate that measurement since, you probably don't even have to graph at all in a test. But they say that how do you draw the parabola as accurate as you can without a graphing utility? You see that this looks like a hyperbola, right? It opens up in one way or the other, but it doesn't have the asymptotes to guide the graph, right? So it's very hard for you to tell how wide or narrow that parabola has to open. And people figure that there is a segment passing the focus, but being parallel to the directrix or being perpendicular to the symmetry axis. And it's going to intersect, right, the parabola at these 2 points, and the length of that segment, see that from here to there, that's how wide or narrow, right, the parabola has to open, is guaranteed to be equal to 4p. So whatever that p is, 4p taken absolute value will be how long the segment is. if you have a long segment like that, it means the parabola has to be open really wide. And we call it the latus rectum. Okay, or that kind of a special, it's right there. Okay. So now, as you can see here, we have a vertical opening parabola, but with a negative p, right? Because 4p is the number in front of that variable, whatever is not getting squared. So p is negative, which means that it opens downward. So by finding the vertex, which is still at the origin, right? The focus is going to be down there, because remember that the parabola is going to open towards the focus. If it opens downward, right, the focus is going to be down there at p units away from the vertex. Therefore, it's -2, right? 0, -2. And the direction is going to be the line that's on the opposite of the focus, that place it at +2. So now, if you want to know how wide that parabola opens, so you're going to have the length of that segment, which is known as the latus rectum, measures to be 8 units, because again, it's 4p. But p is negative, so you take an absolute value. Okay. So you have all of that, right? And pretty much you can read off everything based on a little sketch, right? Knowing the way of it opens, right? And the p units. And again, as you can see that here, this guy has a large p. I don't know if you can tell that p is 5, right? So a large p meaning that 4p is actually a big segment, right? Therefore, the parabola opens, pretty wide. Okay. So now at the end of the day, it's just like the ultimate goal you have to reach, when we discuss the shifted ellipse, right, or a shifted, hyperbola. So we do have something very similar to the let's say the parabola, right? So now what we could do is so I would like to see if you guys can figure this out. Right? Not right now. Right? So before you see me on Friday, not on Friday, on Monday. Because the quiz is going to be on Monday about the 10.1 and 10.2, right? So let's say I might just extend the 10.3 to Monday night, right? Because I think that I pretty much finished the parabola. So I just want to do some final touch to make sure that everyone's okay with the completing the square process, right? So we will extend 10.3, right, to Monday. Okay. So over the weekend, please make sure that at least get the homework 10.1, 10.2 completed, because you're going to have to do that to review for the quiz. And please look over the review packet for chapter 10, if you could, and also the review packet for chapter 4. The quiz will be on Monday, and we will finish up the 10.3 and review for chapter 4. Okay.